Not a straight line. Look at it carefully, it's gonna throw you. -3 if x is equal to 0. Anthony. It's a point. And where's that point located, Anthony?
On the y-axis.
On the y-axis, exactly where?
On a -3.
Beautiful. Right, perfect. The next one, I threw in one we should recognize. It's a quadratic, it's a parabola. And what is a parabola? Not all of it. By constraint, I want only the piece here. So I'm just get a piece of a parabola. So I got a piece of a parabola. Anthony says this is a point, and I got a piece of a straight line. What a mess. Now what could I do for you on Friday? I'd have a square root as one of my pieces. Wouldn't it be fun? I could have x cubed. That's one of the pieces. I think this one's doable, I think. Let's see what's going to happen here. Guys, if I take time to graph this, let's do this first. In the blue, which I think helps, let's plot a few points. And it says I may start out with -3, that's the way it's read, and I got to stop at 0 in my table. That's what the constraint says to do. Now, there's lots of numbers between -3 and 0 I can also try. So it's anything in between. It may not take much here, guys, since this should be a piece of a straight line. Let's try what would you like to try? Maybe a -2? That's true? You can try -1, something else. I'm gonna try those. We're gonna put those in. If I put -3 in, that's a -6 plus 5. Do not let me make a mistake. -1. Put a -2 in, -4 plus 5 looks like a 1. Put a 0 in, so you end up with a 5. Now I'll come back to that, plot those points and see what this looks like. The red one, oh my goodness, Anthony says, Professor, don't worry about that one. It's merely a point. 0, -3. No table needed. The next one in green, yeah, that's constrained here. You gotta try for your x's here is greater than 0. I'm gonna start out with 0 though. And greater than 0 like 1, like 2, anything else you wish to use. That might be enough there. Now if I put the 0 in, of course I get 0 squared plus 1 gives me a 1. So I'll consider that. I'll put a 1 in, I think you end up with a 2 for the green. Put a 2 in, I think you end up with a 5. Now I know some of my students who may have seen and can work with piecewise functions fairly quickly say, oh, Professor, that looks so elementary. I talked to a class where some students have not had this for a while, or may not have ever had it. So I gotta be very careful. Now, let's see what this graph looks like. Plotting points and being careful whether a point should be open, closed. Now guys, I'm gonna move over here. You see all this? Mr. Parker, as I move around, are you okay with the recording?
Mm-hmm.
You move around with me?
Mm-hmm.
Okay. Oh, by the way, guys, we're moving into a new building in the spring. I think you guys have heard about that. Beautiful building. Beautiful building. And when I walk into a classroom in that new building, after we leave this old building, if I have to do Zoom, I can do Zoom right there in class, and we have cameras all over the ceilings. Guess what? The camera follows me as it records. Like Mr. Park now is taking his hand to remove that camera. No, the cameras are there in the new building. Okay, guys, let's get the blue one out of the way. Oh boy, here goes. -3, -1. You mark these. Be careful, I try to be as neat as I can. And looks like that might be enough. Okay. Now let's get the blue one out of the way first. -3 down 1. Do this. Keep ready for it. Checking my numbers here. Down here at 3 should be there. Up to 5, up to 1. I gotta see if this is what I got for you. Okay, negative 3 down 1. Guys, negative 3 down 1, right here. Am I supposed to include that point, darken it in, or open? Based on what you see here. Was there an equals mark at negative 3? So I should include, in other words, darken it in, we'll start here. The next one looks like negative 2 up 1, if we have no mistake in the math here, looks like it's up here. And then got 0 up 5, it's up here. Connect. On top of the board here, so let's connect this the best we can here, guys. We said there should be a piece of a straight line, so let's make it look reasonable. And have that. Is that reasonable? Is that a piece of a straight line? Oh, did I make a mistake?
Shouldn't the 0,5 not be included?
Where was it? Where was it? On my table here? Oh, down here. Are you talking about here?
Yeah.
Okay, got negative 3. We started with negative 3. Now I picked up negative 2 up to 0.
Shouldn't it not be included? Because
Oh, was it? Oh, you mean from the handout, was it included?
oh, it's not
You just
included.
wrote it as a proposed point is where she's confused, I think,
Mhm.
on the graph.
Oh, 0 up 5, right here you were talking about.
Yeah.
Okay, got you. I got you. You're saying, Professor, right now. Got you. That should be open. Thank you. Where it looks. Now, negative 2, 1, 0, 5, we got that out of the way. The red one, this is what Anthony was telling me. He said, Professor, the red one just says go down to negative 3 and darken it in. Do we agree with that? That's piece number 2. Piece number 3 in the green, I've got the points to work with. Now guys, it says 0, 1 first. Well, 0, 1's right here for the green part. 0, 1, should I include it? That initial point right here, 0, 1, based on what you see here, should it be darkened in or open? It's open, right here. And my other points, if I'm careful here on top of the board here, out 1, up 2, definitely is going to be here. And then finally 2, up 5. That's in there. This one, guys? Now keep in mind, this should be a piece of a what? Parabola? So when I connect this time, let's do it free-handed. Maybe something like this, we make it look like it should look. And looks like it was from here up. And looks like it goes forever. Wow. Is that it? I see some students looking like, whoa, where'd that come from, Professor? Guys, is that reasonable? Do we have the 3 pieces, or is there something messed up? Mr. Park, June, are we okay on this? Is the graph now the 3 pieces look reasonable? By the way, now if I use the vertical line test, is this going to pass the vertical line test? I was a little worried at first, because I thought, whoa, hold on. These 2 points, are these 2 points so okay for the vertical line test? Yeah, because this one's not to be included to begin with. So I'm thinking, or this one. So I think we're in good shape, are we? And there's the graph. Now, could you do one of these with 6 pieces Friday? This one has 3 pieces. Now, if you agree with that, guys, I'll move to the next one. Now, someone from the handout tell me, did I ask you about the domain, the range? Oh, I did, on this graph. Ramsey, you are good. Here we go. I want to know what the domain of this graph is. From left to right. X-axis. Guys, looks like the furthest to go to the left is negative 3. Is that negative 3 included? I can say, well, let's start out with bracket, negative 3. Now, this is the domain instead of x's on the x-axis. Now, how far out does it go? Implied here, the way I look? Is it gonna go through infinity? Place infinity? Now, my clever students here, what may slow you down? So wait, Professor, you've got to be careful. What may slow you down, because I see some points are open as I go from -3 all the way through infinity. These two are open, and we're saying, no, go ahead and include, for the domain, include it. Anyone give me a rationale, why am I allowed to include, and just make one full sweep, and I'll pick up those, the domain for those open points. Yes?
Is where the open points and the included you have the x of the 0, -3.
Ah, beautiful. She said, wait, Professor, this point down here picks that up. All right, guys, was this 0, 1? This is 0, 1 open, so 0 was not picked up there, so I could not include 0 in my domain. This is what, 0, 5? And again, that's open, not supposed to include 0, but as she described, but Professor, this one down here does pick up 0. So that's why I'm allowed to have 0 there. Now, you talk about a mess if that red point was not included. I'll consider that after I finish up this one. Guys, the -3 through infinity looks good for the domain. Now the range, be very careful. Let me do this. That's the up and down. Now, it might be a little awkward to describe that, but I like to know the up and down the y values. How far down does it drop? -3. -3 is all hanging on by itself down there. No interval, just -3. I got -3, I'll write like this. Now put union, put a comma. Now let's pick up rest of it, if we can. Now we're moving up and down the y's. So this is the lowest it dropped, now we're up to here. Anyone describe maybe from here up, describe what's going on there in terms of the y's. Anyone? I'll label this point for you, if that would help. I think this was -3, -1. So can anyone describe for me the remaining part of that range? Yes.
Must be -1 bracket, to infinity.
Okay, -1, and that -1 is supposed to be included, he's looking at the y. -1, he says, bracket,
Yeah.
I can tell me more,
And then to infinity.
through infinity. He says, Professor, the y value here, -1 is to be included. If you look at the y's for the range, it goes up, and it looks like this arrow indicates it's gonna go forever. Is that true, guys? Now, what points would I be concerned about? This open point. Is that open point, though, saved for me? Is there a point directly across that is now darkened and picks up that, maybe that y value I thought I could not use? You guys agree with the domain and the range? Now, something I did not have on that handout was, I always place this on the exam. Can a student look at the piecewise function? Here it is, 3 pieces. Here's this graph. Could you do this for me? Find this. Let's try, f of the -1 plus 2 times f of 0 subtract f of 10. Now, what are we accustomed to before we saw these piecewise functions? We're accustomed to, Professor, something like you did on that quiz last night, the very last problem of the quiz. They give you a function and ask you to plug in a number here. I've got 3 pieces here. It says find f of a -1. Does that mean go back and replace x by -1 here, look at here, and here? No, it wouldn't be a function. Anyone tell me, what are you going to do to find the value for f of a -1? You're going to find which of those 3 pieces does -1 fit. Is -1 in this condition? Is -1 caught between -3 and 0? Then I'll use the blue to get the answer for this. That says this is 2 times, from the blue one, -1 plus 5. I think you're going to end up with a 3. Next says 2 times f of 0. Well, f of 0, right here's 0. It says now to use the red. So f of 0 using the red is -3. So it says 2 times -3. And help me out here, guys, that's plus, let's call it -6. And then subtract f of 10. I think 10 fits the green. 10 is greater than 0. So use the green. That's 10 squared plus 1. Which I think becomes 101, is it? Let's step back and look at it. Is that true, guys? Then put all your arithmetic together. What is it? 3 minus 6, -3. Is that -104? I did it quickly. Is it -104 altogether? You have to determine when you see one of these defining pieces, which piece am I going to, Professor? It all depends on that restriction, that constraint that you're going to be using. Now guys, take a close look at that. This is 1.4, I think. I have only one more example. Is this making sense? But you got to be very, very, very careful. Especially, and not lose points on the exam, especially with, is this open or is it closed? Is this open or is it closed? So be careful there. I think the other parts will work out for us. Any concerns here? Yeah. Now, am I going to be asking you, if I teach Math 7, am I going to be asking you to do some calculus on this? Of course. Mr. Park, did you guys do some calculus on piecewise functions, or do you recall? Or June?
We use calculus to graph it.
Oh, you used the piecewise function to graph the function.
Yeah.
Okay. And then did you find some limits, maybe? The limit is x is approaching this, the limit is x is approaching that. I think what they did was graph it and found some limits, I think. And guys, these two are experts over here. Give a shout out to June. June's telling me she's already had Math 7, Math 8, Math 11, Math 15. And she wants to go to Berkeley. She's going to Berkeley. And she wants to do, what was it, applied math. Mr. Park, he's already done Math 2 with me, Math 7, Math 8, and he's in Math, help me out, 10?
15.
Which one?
15.
What do you think? 13?
15.
15,
Yeah.
15, I'm mixed up here. And he's about to finish up. Wow, so you're talking about 2 experts? We've got 2 experts here to help us. Guys, stepping back, look at this, any concerns here? Now I see heads nodding yes. Now I know how students are, I've been around long enough. I'll see a classroom, I'll see students doing this, ooh, yes, mm-hmm. Pass out the exam on Friday, mm-hmm. The head goes the other way. Because I'm sitting here watching, I see your head. Oh, I thought you nodded this way when we did that in class. Professor, yeah, I nodded my head. But what are you not saying, shaking head? No, when you see that test. Because you gave me 8 pieces in a piecewise function. You didn't give me 3 like you did. You give me 8 pieces. I'm not gonna go crazy on you. I'm not gonna give you 8 pieces here. Guys, let's get the last one out of the way. That'll be the end of that particular section. I'll just squeeze it in right here if I can. And we'll move on here. The next one says g of x. And looks like the pieces are, let me use the same colors here, 4x plus 8. And the constraint is if, in this case, x is less than, like -2. Next is x squared subtract 4, is that red? And here the if, the strength there was this. And the third one, oh, I did throw in a square root. Square root x subtract 2 if X is greater than 2. You've already heard my two experts back here. This will follow you. You're going, guys, going to Math 7, you're going to see it again. Okay, guys, let's be patient here, very patient. By the way, tell me at this point, are the tables on the side here helping to construct points before you get there? Some students may not need that, but I think it helps in a sense here. The first one, guys, 4x plus 8. I hope you can tell me that's mx plus b, and that's going to be a piece of a straight line. Now, what piece is it? Well, that depends on this. By the way, we all know 2 points determine the lines. I'm going to just plot 2 points here. I'm going to start out with -2. Let's try -3. -2 taken back. 4 times -2, of course, is a -8. -8 plus 8 gives me a 0 to consider. A -3, 4 times -3 is a -12 plus 8 is a -4. And I'll come back to that. The red one, let's get that out of the way. Our table says I may start out with -2 and go up to 2. Let's try something in between, try 0. And that may be enough. That's right, guys? Now, -2, take them back. -2 squared is 4. 4 subtract 4, 0. Put a 0 in there. 0 squared subtract 4 gives me a -4. 2 squared subtract 4, 0. Wow. That's the red one. The green one. That's square root. Do it here, guys. Yeah, I'm going to start out with 2. And we'll try 3. We'll try 4 also. Satisfy that constraint. Put a 2 in there. That gives me square root 0, which is 0. It's coming up quite often here. 3 gives me a 1 underneath there. Square root 1 is 1. And I realize if I put a 4, that gives me a 2. That's square root 2. Now that should be enough to get the sketch. How do you think? Here we go. I think you'll appreciate these condensed versions of these sections. This is done. 1.4 is done here. Okay, guys, let's see what's happening here. Okay, let's get the blue one out of the way first. Anyone tell me, oh, we've already said, it should be a piece of a straight line, mx plus b. -2, okay, back to -2. Well, okay, -2 is 0. And guys, looks like the way it's presented to me, -2, 0, the beginning will not be included. See if you guys agree. Looks like it's right here. Next is -3 down 4, if I have no mistake. Patient here. Of course, that point is down here. -3, -4. Connect. Are we looking at this as a piece of the straight line? That marker worked, there we go. That looks like that. Is that the first piece? Yes, no? Okay. Second piece, the red one. The red one should sketch into a piece of a parabola. Now, so if you use my table to see what that piece looks like. And the table says -2, 0. Oh my goodness, that's where I was on blue. -2, 0. May I include this time in the red, -2, 0. The way it's written. I see a less than or what? Equal to, the equals mark says now you get to color this in. You get to include it from the red. It goes over to 2, and it looks like I got 0 down 4. Oh my goodness, okay, in the red. 0 down 4 is here. end, looks like I got positive 2, 0. That's fine. Over here, positive 2, 0 in the red there. It looks like, guys, at the end, I cannot include it. It's open. Please tell me, is that going to look something like this? That's a piece of a parabola. Last piece, the green. The green from yesterday should look something like this. The graph of it, something like that. And we know what that looks like. It's like yesterday. Let's plot the points in green, guys. I got 2, 0. Oh my goodness, I'm right back to where the red one left off. Now in green. Is that 2, 0 supposed to stay open though, based on the green? Or may I close it in? Does it remain open? I don't see an equal sign here, do you? Okay, so it's gonna stay open. And then I got 2, 0, which I'll show again in the green here, it's still open. Then I got out 3, up 1. Here we go. That means I have a point here. And out 4, and someone's going to help me on this one, out 4, square root 2, I think, came out. 4 there. Do you want to know the approximation for square root 2? What's that close to?
1.7.
There again.
1.7.
No, you're a little bit too high. But it's 1 point something, right? Definitely it's 1 point something. I think it's 1.4 something. Okay, so out 4, up 1.4 something. A little bit higher, I guess, than the last one. Put it right in there. Connect, guys. Do we see a shape that looks something like this? Stretch it out. Something like that. Is that the way the square root graph on that parent graph looked yesterday? Let me step back. What a strange little graph. That's it. You guys agree? Is that the graph? I hope so. I'm lining up the board sometimes, though. Yeah.
I have a question about why, the point at, -3, -4 is, circled.
Okay, I'm trying to find where I am here.
It's other blue line.
Oh, -3 now, right here?
Yeah.
Beautiful. Guys, good question. The one that you're concerned about whether it's going to stay open or closed is always the initial point. The others are always darkened in. It's that initial point on each one of those will be darkened in or open. Everything else is always open. Good question. You guys agree with this graph? Did I ask for the domain and the range on this one also? Okay, domain. From left to right. Oh, I guess I think this was really easy. I think. I'm gonna be careful myself. Cute. Okay. Anyone venture out and tell me what the domain from left to right is in interval notation, the x's? Go for it.
Negative infinity to infinity.
Okay, now. You said that's from left to right, looks like it includes everything. Does it really, this one got us, does it really include all?
It needs to be negative infinity, comma 2, union.
Hang on.
2.
Negative infinity up to 2. Then union to more.
And then 2, comma infinity.
I love it. Look at that. I can't use that. Hold there. I thought when I first played, oh yeah, it's negative infinity to positive infinity. It's not. Thank you. Range. The up and down. How far down does it drop? Well, it looks like this indicates it's dropping forever. So it's negative infinity. How high up does it go? Well, it looks like, I realize this is leveling off, it looks like it's going to be going up also. Is it through positive infinity? Is that the range? From negative infinity through positive infinity? Yes or no? Are we still concerned about this point right here? On the range. I know if I should label that point was 2, 0, and my student just gave me for the domain, I see the domain, the x is a 2, he says, Professor, for the domain, you get used to. Now, can I use 0? That's the y, can I use 0 down here? If not, I don't know, guys, I don't know, by the way, can I? How about this point here? If I label it, that would be labeled as what? Negative 2 what? Now, is that 0 being picked up here? So is it negative infinity through positive infinity? I'm picking up all points now. Beautiful. What a lesson. To get 1.4 finished. Yes.
So if that one happened again, then it would not be.
Exactly. That's why I was looking for it. 0 is not to be included here because it's open. Now searching the graph to see is 0 picked up somewhere else. And it was being picked up on this point here. By the way, if this point here were open, we'd have issues. Since I'm supposed to know it picked up 0. Wow. Guys, any concerns here? 1.4 is finished. Yes.
Could you show us what it looked like if 0 wasn't included, and how you'd read it?
What's that now?
How would you write it if 0 wasn't included?
Oh, if this were not, let's do it. Mr. Park, June, look at this, what the students are asking. Now suppose it looked like that. Am I allowed now to pick up for the range? Can I now pick up and call it negative infinity through positive infinity like we thought earlier? Or not? Okay, I'm seeing a head shake, no. Beautiful, beautiful question. Mr. Park, tell the class what would happen if this had been open. Oh, you asked me a good question here. What would the range now, do you think, look like?
It'll be parentheses negative infinity.
Negative infinity?
Yeah.
Up to what?
0.
Oh, or is it 0? But look at the range.
Yeah.
Okay, and
Union.
anything else?
Union.
Union? Okay.
Yeah.
Oh, you don't need pieces for me. What else?
And parentheses 0 to infinity.
So, oh, from there on, you're saying this.
Mm-hmm.
You guys agree? Okay, therefore it says you're not to be able to use 0, and sure enough, you can't use 0, that we're open. Odd, beautiful question. Just so happens, we lucked out here, it's close in. I guess you got this. What's the answer to this question? 1.4 is done. I'm not watching my time here, time goes by too fast here. Everybody complained. 3 hours is not enough. Could we maybe stay 5 hours a day? I look at the smiles on students' faces. Like, Professor Hawken, wanted to hear that for so long. Yes, we need more time. This time goes by too fast here. Okay, before we take a break here shortly, that 1.4 is done. Now, flip it over. Did I have something on the back? I did I not? But we're gonna do something here as I pass out your quizzes to you. But we're not quite ready for it yet. I know I've got some grids on the back, and we're gonna do a little graphic for you shortly. But first, I need just a student to read for me. To go into 1.5, I can't believe we're moving into 1.5. Already. You guys call this, it's part 2, I think it's part 2. Okay, call it part 2. This is all about this. I'll have just enough time before the break. Do this. Well, first place a function on the board for you. Then we'll have a student who sort of read for us. We'll call this function this. please tell me, would the graph, when I finally get the graph for this lengthy function, will it be a parabola? I see the x squared stair there. It's gonna be a parabola. Now, is it gonna be a parabola opening up, a parabola opening down? Is it shifted over to the right? Is it shifted over to the left? Is it upside down? What on earth is going on? This is where these transformations are supposed to help me. Now, I need a volunteer to read for me. Who would like to read? Just read those steps on the other side about transformations. Anyone want to read the steps for me? Yes, first.
Change the part.
Yeah, read the first
First,
transformation.
shifts of graphs. To graph y equals f of x plus c, shift the graph y equals f of x upwards, c units.
Okay, beautiful. Now, you said y is equal to f of x plus, was it c I called it?
C,
B?
a c.
Oh, c.
Half.
Like that? And she says, Professor, if it somewhat looks like that, this on the end tells you to vertically shift the graph up. Would that be happening here? Do I have a number to be associated with what she calls C here? Is that? That says when I finally get into it and graph it through transformations, which we'll eventually do, I'm supposed to vertically shift down 6 units on this graph. That's gonna play a part. Tell me the next transformation.
Well, that was the first.
That was for the other one. Yeah, let's take care of both those. Get down to the next slide.
Horizontal shifts of graphs.
There you go.
To graph y equals f of x plus c.
Okay, hang on now. Y is equal to f of x plus c. Okay.
Shift the graph y equals f of x to the left, c units.
Thank you. Shift to the left. Now, I think the next one was y is equal to f of x subtract c, maybe?
Yes.
And if I see it, that looks like that, it's gotta look like that though, we shift to the right so many units. Is there a piece of my function up here that particular transformation may be applied? All right, I got the first one out of the way. I see there's gonna be a vertical shift down 6 based on what she told me from the first transformation. Might, the way it looks right now, might you see a spot somewhere that tells me, Professor, that graph's going to be shifted horizontally over so many units, either to the left or to the right? Anyone have an idea? Or does anyone see maybe an issue with trying to apply that transformation